here at gotomath.com, click on the calculus. Let's go down to limits at infinity and 1-2. 1-2. If you don't like the graph, this is a really cool graph. Check that out. If you don't like the graph, we can always click on it. That's got actually a vertical asymptote in it. That's what this line is right here, indicating there's a vertical asymptote. We'll just stick with this graph. How's that? Now, um, there was a concept back when you took college algebra or just an algebra class when we talked about horizontal asymptotes and how to find horizontal asymptotes. Okay, so basically that's what's going on here. We're just finding the horizontal asymptote, but we're looking at it through the eyes of the calculus telescope. I'm going to write this one down. We got 7x plus 4 over 6x to the 10th plus 13. Get that written down. Okay, so let's go over to the whiteboard. We got that written down, and then we'll come back to the graph. So we have the limit as x approaches infinity, and we had 7x plus 4 over 6x to the 10th plus 13. Alright, so this is how we're going to determine this. First off, if we went ahead and evaluated this, we'd end up getting infinity over infinity, right? So this is just going off to infinity as x gets larger and larger, and this is going off to infinity as x gets larger and larger. So this is an indeterminate form, right? Indeterminate form. So what we're going to do here is we're going to look at the denominator, and you want to choose the leading term. That's going to be the term with the largest exponent. For example, this is x to the 10th, so this is the leading term, has the largest exponent. And then what you'll want to do, so let me just rewrite this. This is a really easy section, I promise. What you're going to do is you're going to divide each one of these terms here by x over 10. Divide this by x over 10, this by x over 10, this by x over 10, and this by x over 10. So 7x to the 10th power plus 4x to the 10th power, and then we end up having 6x to the 10th power over x to the 10th power plus, and then 13x to the 10th power. Okay, and then what we'll do next is simplify if we need to. For example, this can be simplified to 6. Right, this can be simplified to 6. Okay, but actually let's just go through and do this without having to simplify. We know what that is. We know that's 6. So if we took the limit as x approaches infinity of 7 over x to the 10th, right, as this number gets larger and larger and larger, what's happening to the whole thing? Right, for example, I'll just write some example terms down. If I had 7 over 1, and then let's say we plugged in 2 into that, so that'd be 2 to the 10th, and then we had 7, 3 to the 10th, let's say 7, we're going to jump out here, 20 to the 10th, right? Well, what's happening to the whole number? It's getting what? Since this is getting larger and larger and this is staying the same, the whole thing is getting smaller and smaller. And as we go out to infinity, as this number gets larger and larger, what's happening to the whole thing? It's approaching 0, right? It's going to approach 0, get smaller and smaller and smaller. So this term here is going to go to 0, right, as x goes to infinity. And then, of course, this term here is going to go to 0, right? Okay. Now this simplifies down just to 6, so we'll just write 6 here. And then of course this here is going to go to 0 also, right? It's going to go to 0 also. So what are we going to end up with? 0 over 6, which is 0. 0 over 6, which is 0. Okay. Now here's a quick shortcut on this. If you have the leading term in the denominator, if its exponent, which is a 10, is larger than the leading term up here in the numerator, which is x, and it has, or 7x I should say, but x has 1, right? This numerator, the denominator, or the 10 is larger than the 1 here, so this can always go to 0. Okay, no matter what these numbers are here, this is going to always go to 0. So it's basically going to boil down to these two guys right here every time. Alright, it's going to go to 0, but this is how we actually are going to some way determine that. Okay, so that limit is actually going to 0. Okay, now if you look at the graph, look what's happening to the graph here as x goes out. Now we're heading out in this direction. We will look at some going back in this direction, but you can see here that the graph starts getting closer and closer and closer and closer to the y-axis. In other words, the y value is what? Approaching 0 as x gets larger and larger. Of course, I know this is, you know, a snapshot, a small area of that picture, but you can kind of see what's going on. All right, so let's go up here and make sure the script is all good. So we got 0. Okay, and you can always click on the video there to watch this again. Okay, so anyway, come on over to gotomath.com. We'll be talking a lot about this. All right.